Okay, here we have some special triangles, and we need to know some things about them. First off, our hypotenuse is 1 on both of these. 45, 45, 90, 30, that's supposed to say 60, 30, 60, 90 triangles. Recall that the short leg, if you double the short leg, you get the hypotenuse. So what number doubled is 1, that's a half. Okay? And then we know that this leg is root 3 times the short leg. So you get root 3 times 2. Now, for these legs, we would get, if it was x squared plus x squared equals 1, because both of these legs are the same. So we would get 2x squared equals 1. We get divide by 2, x squared equals 1/2. And then we square root both sides. We get x equals, well, the square root of 1 is just 1 over the square root of 2, which mathematicians don't like, so we do some math to it, and we end up writing it as the square root of 2 over 2. So that's how long this side is, the square root of 2 over 2, and this side is also the square root of 2 over 2. You know what, I'm going to move that on to the other side. Let's look here and find some things out. Sine, cosine, tangent. We need to remember last year, SOHCAHTOA, right? Where if we have sine, we know that it's the opposite over the hypotenuse. If we have cosine, we know that it's the adjacent over the hypotenuse. And if we have tangent, it's the opposite over the adjacent. Okay? So I can figure out some exact values of these using these ratios and these angles here. So let's start off by looking at 30. 30, I know, for sine, is my opposite divided by my hypotenuse, and 1/2 divided by 1. Anything divided by 1 is just going to be a half. If I want to know my cosine at 30, I have to take my adjacent and divide it by my hypotenuse, and I get root 3 over 2. And then if I take my tangent, I take my opposite and divide it by my adjacent, so I get 1/2 divided by root 3 over 2. To divide by a fraction, you flip it and multiply it, so I get 1/2 times 2 over root 3. The 2 and the 3's cancel, or the 2 and the 2's cancel, and I'm left with 1 over root 3. Again, because the square root's on the bottom, we don't like that, so we do some math to it, and we get root 3 over 3. Oh, that looks terrible. But what happens at 60? Well, now we're looking at this angle, so things are going to change, right? My opposite is now 3 over 2. Well, my hypotenuse stays at 1, so I'm going to get root 3 over 2. And my adjacent is now going to be a half, and my tangent is root 3 over 1/2, or just root 3. Okay. For the 45-degree triangle over here, both my sides are root 2 over 2. So it doesn't really matter which angle I pick. My opposite and my adjacent are the same. So for sine, it'll be root 2 over 2. For cosine, it'll be root 2 over 2. And for tangent, root 2 over 2 divided by root 2 over 2. Anything divided by itself is just 1. If you can make a nice version of that chart and keep it somewhere, it's going to be very helpful when we do reference angles and figure out values, exact values of other angles. Oops. The last thing I'll talk to you about here, man, why is that still recording? Is when we have a situation that occurs like this. So I have this angle. Let's say it goes out to here, and it goes through this point here. And that point is 4 over and 3 up. Right? So notice I can make a nice right triangle by just dropping lines across here. But I know that this has gone 4 over and 3 up. So I'm not really sure what that angle is in there. That's my theta, but I don't know it. But I can find out what my sine ratio, my cosine ratio, and my tangent ratio are. Simply by, sorry, I lost my train of thought here, looking at this relationship. So the first thing I need to know is how long is my hypotenuse? Well, I can take 3 squared and 4 squared, and that'll equal my c squared. Oops. So 9 plus 16 is 25 equals c squared. Square root both sides, and I get a lovely hypotenuse of 5. So now I can come up with my ratios. Looking at this angle, here's my opposite, here's my hypotenuse. The sine of whatever this angle is 3/5. The cosine of whatever this angle is my adjacent side over my hypotenuse, or 4 over 5. Alright, my tangent is my opposite over my adjacent, so I can say the tangent is 3 over 4. This will be how we figure out the exact values going forward. We'll have to use Pythagorean theorem to figure out either the side or the hypotenuse, and then use those ratios to determine what our value would be. We could then use this and go sine to the -1 in our calculator of 3 over 5 to figure out what our angle actually is. But I don't have a calculator handy, so I'll leave that for you to tell me on Monday.